Okay, in this video, we're going to do the notes for 11.5, and they're all going to focus around polyhedron. So a polyhedron, here's our word, is a solid bounded by a polygon. So the simplest polyhedron that we know, that you're probably very familiar with, is the cube. So to do a cube, what you would do is draw your square. Okay, so here's my square. It's pretty small, but that's okay. Then what I would do is I would circle that square, and I would say copy. And then I would say paste image, and then as you paste it, kind of line it up. Say that looks pretty good. And now watch what we're going to do. We're going to connect, we're going to connect these lines and get a cube. Okay, so this is called a cube. And the front face, or if you prefer the back face, let's see if we can highlight this a little bit. This back face back here is a square. And every side is a square, but this will give us some perspective for you. So that back face is a square. That's a cube, and it's one of the polyhedron. Okay, you can also do another shape, and let's try another polyhedron. What if I start with a triangle in front? So here's my triangle. Oops, let me try that again. So I don't like that one. Okay, so here, here, and here. That's a triangle. And then I'm going to do the same thing. I'm going to copy this triangle. I'm going to paste it right behind it. And I'm going to line this up a little bit. Let's say like that. Okay. And now I'm going to connect the vertices. 2, 3. And you have another polyhedron that has a triangle base. So let's just shade in the back base so you can get some perspective. So here's your back base, and that's a triangle. Okay, so that gives us some ideas. So let's fill in some more of these notes. The face are the polygons that form outside the polyhedron. Okay, so here is your face. So let's change color. Okay, right here, and the blue in the background is a face. Okay, let me do other things here. Let's put little red dots on all the corners. Okay, every single corner is having a red dot. Those red dots are called vertices. Them are called vertices. A single one, so if I do these together, a single one is called a vertex. Okay, so we'll write that down in a second. Okay, then I have another vocab word for us. Look at the sides of these shapes. So here's a side right here. I'm going to do an orange. Here's another side. Here's another side. Side, side, side. Okay, they're all sides. All of these sides are called edges. Okay, so the edges was what we did in orange. Okay, so let's keep defining things as I'm kind of going back to these pictures. Okay, a line segment formed by the intersection of two faces is our edge. And we just talked about that in orange, right? Okay, a regular polyhedron. If you say a polyhedron is regular, then all the faces are congruent, regular polygons. Okay, so congruent and regular mean the same, right? Well, they're all congruent and they're all regular. So what does regular mean? All sides and all angles are congruent. Okay, a vertex is a point where three or more edges meet, and I'll say the plural equals vertices. Okay? All right. We're going to talk about classifying these polyhedron shapes, and there's two ways to classify them. One classification, so this is the first one, is prisms. And when you have a prism, the two bases are congruent polygons in parallel planes. Okay, well, that sounds pretty confusing. So let's go down here. Okay, so these right here, that's a prism. How come? Because the two bases are congruent polygons in parallel planes. So that means you have to have face parallel to face. And you have a face here that's parallel to this one. And so they're all parallel. So that's what makes it a prism. So prisms are parallel. Pyramids, you have simply one base. Okay, I have one base of a pyramid, and that's a polygon. So a pyramid is a polygon with just one base, and here's an example of a pyramid. Okay, let's highlight this a little bit. Okay, so a pyramid has a point up here, and it has, let's highlight the base down below, it has only a single base. So I'm going to say it has one base and a point. Okay? Okay, so now I know a little bit, and this was number 2 is pyramids. I know a little bit about these shapes, but I don't know how to rule out other shapes. So what makes something not a polyhedra? So polyhedron is the singular. This is the plural. So what makes it not, in the case, a polyhedron? Well, if you have a curve, okay, these curves, all of these curves, spell that correctly, all of these curves, here, here, here. Okay, so I'm going to say polyhedrons do not have curves. Okay, if it has a curve, it's interesting shape, but it's not a polyhedron. So here are some famous Platonic solids. So you have different things here. Here's our cube. Here is a regular tetrahedron, has 4 faces. A cube has 6 faces. A regular octahedron has 8 faces. A regular dodecahedron has 12 faces. Okay, and so on. So these are Platonic solids. We're not going to really talk about them other than maybe the cube and maybe the rectangular tetrahedron. But let's go on to other shapes that we will talk about. So here is an example of how to identify if you have polyhedron. And so look for all the ones that have a curve. If it has a curve, we're going to eliminate it. If it has a curve, we're going to eliminate it. Okay, everything else qualifies as a polyhedron. So how will we name these? Well, we have some prisms and we have some pyramids. So right here, the very first one, that's going to be a rectangular prism. It's a prism because you've got parallel faces, and it's rectangular because the shape of the base is a rectangle. Okay, the next one, that base is a hexagon. So that's going to be called a hexagonal pyramid. Okay, so that's another polyhedron. And then let's go to another shape. Here is a square pyramid. Notice the pyramids have one base and they both have points on top. And here's a third shape, and this last one is a triangular. Notice a triangle base, triangular. And is it a pyramid or a prism? Well, there's no real point, so it's a triangular prism. Okay, now what I want to start doing is talking about a theorem called Euler's theorem. And I want to tell you what it is first. Oh, sorry. It's not pronounced Euler's. It's pronounced Euler's. Euler's. So this is Euler's theorem. And what he observed is that if we know the number of faces, so this is faces, in a polyhedron, and we know the number of vertices, then what he observed was that the number of edges plus 2, so these are edges, will always equal the sum of the faces and vertices. Well, that's interesting. That means that if I know the faces and the edges, I can calculate the vertices. If I know the vertices and the edges, I can calculate the faces. And if I know the faces and the edges, I can calculate the vertices. So there's lots of ways that you can use this formula. Now what I want to do is identify the faces and the vertices and the edges of each of the shapes above. So look at the rectangular prism. How many faces do you see? Well, there's top and bottom, that's 2. Side to side, another 2. And back and front is another 2. So that should be 6. What about the vertices? I frequently will just color them with red dots. You've got to make sure you account for all of them though. So that's 4 right there. And there's another 4. So that's 8. So the vertices are 8. So how many edges could we count? Here is an edge right here. Here's one right here. So we can count the edges, or we can say, if I know the face and the vertices, so this is 14, that equals edges plus 2. Therefore, the edges must be 12 by using Euler's formula. So let's do that again for the hexagonal pyramid. How many faces do you see there? Well, the way you can figure that out is you say, okay, it's a hexagon. A hexagon has 6 sides. So there are 6 faces that go up in the air. So that's 6. Plus there's the base, and that makes 7. How many vertices do you have? Well, again, we can come in and we can put little red dots on things. So 1, 2, 3, 4, 5, 6. That's each of the corners. Plus 1 more is 7. So I also have 7 vertices. Now, let's figure out the E by doing this formula. So 7 and 7 is 14. 14 equals E plus 2. So E must be 12. Okay? Okay, let's try another one. Let's look at the square pyramid. Okay, the square pyramid has 1, 2, 3, 4 faces vertical, plus the one on the bottom. That makes 5. Then you can color in, if this helps you, your vertices. Here they are. Okay, that's 4, 5. So in terms of vertices, I also have 5. Okay, let's use Euler's formula. And I know that F plus V is 10. And I know that 10 equals E plus 2. So the edges must equal 8. You can count your edges, but I'm saying to you, if we have the F and the V, we can calculate them using Euler's theorem. Okay, triangular prism. Let's get into that one. So let's see, how many faces do I have? I have 1, 2, 3, 4 faces. No, is that true? 1, 2, 3, 4, 5 faces, because I have the top also. So that's 5 faces. And now let's, I think I'll do blue and do the vertices that way. So 1, 2, 3, 4, 5, 6 vertices. And if I know 5 and 6 is 11, and Euler's theorem tells me 11 equals E plus 2, so that would make E equal to 9. Okay, so now we had some practice time using Euler's formula. You want to memorize this so that you know how to relate faces and vertices and edges. Okay, so I thought this diagram is a little bit difficult, so let me fill it in so it makes it easier. Here is our vertices right there. They're the blue dots. Another blue dot. Okay, draw these out. There we go. Okay, we're going to come down. Here's another blue dot, another blue dot. So hopefully this is starting to take kind of a shape. Okay, so that, and then we have this, we can go this across the back here. There's another dot over there. Okay, so don't think about the individual vertical sections as being separate faces. We're going for just the big faces. Okay, so find the number of edges on the frame of the house. Okay, so we know that F plus V equals E plus 2. So they want to figure out the number of edges. And I was saying sometimes it's hard to count edges. So I thought maybe we'll just count faces. So you're going to have a face here, right, in the front, and a matching one in the back. That's 2 so far. Then you're going to have side and side. That's another 2. And then both sides of the roof, that's another 2. And then the base is a 1. So what am I getting? 2, 4, 6, 7. I think I have 7, but that doesn't sound right. So let me think about this. So how many faces are we getting? So do we have 7 or do we have 8? So let's see. 1, 2, let me count this out. Okay, so looking at this again, let's count how many faces I have. So for faces, I kind of neglected to count this as well. So what I'm seeing is I have 1 here, 1, 2, so 2 in the front, 2 in the back. That makes 4. 5 and 6 on the sides, 7, 8, and 1 more at the very bottom. So the number of faces I have is 9. If I did the vertices, which were all the corners, so let's see if I can back out a little bit. Well, I'm still going to make that a 9. And I'm going to maybe just change to red and do the vertices. Okay, so I have 1, 2, 3, 4, 5. So if I have 5 in the front, then I have 5 in the back, right? So 1, 2, 3, 4, 5, and that's it. So that's 10. So that makes this 19, and since it has to follow that 19 equals E plus 2, then this E must be 17. And if you count these little side pieces here and here, you are going to get 17. And that'll all work out. So that's using Euler's formula. Okay, we can do it one more time right here. Find the number of faces that we have on this octahedron. So let's see how many faces we have. So looks to me like we have 8 faces. So we have this front 1, 2, 3, 4 on top, and then 4 on the bottom. So faces is 4. How many vertices do we have? 1, 2, 3, 4, 5. And then I think 6 is down here, and that's all the vertices. So vertices is 6. That makes 10. So 10 has to equal the number of edges plus 2. Subtract 2 from both sides, and 8 equals the number of edges. Because we know that F plus V equals E plus 2. So if we had 4 plus 6 equaled some mystery number plus 2, we can say that 10 equals some mystery number plus 2. So if we subtract 2 from both sides, we get that mystery number is indeed 8. Okay, so let's keep going. Okay, on this page, what we're going to do is figure out whether the shape is a polyhedron or not. So what I want you to notice right away is this curved edge. So if you have curved edges, it cannot be a polyhedron. So you can eliminate that. This shape is a rectangular prism. And let me see how many faces this has. So I can count the front and the back. That's 1, 2. Sides, 3, 4. Top and bottom are 6. So the faces are 6. I think the vertices are easy to count too. 1, 2, 3, 4, 5, 6, 7, 8. So the vertices are 8. That's together 14. So that has to equal E plus 2. So E must equal 12. Because remember, F plus V equals E plus 2. Okay, so let's look at the next shape, and that is our famous cube that we drew earlier. So a cube has 6 faces, the front and the back, the right and the left side, and the top and the bottom. So that's 6 faces. Vertices, again, I just do them in the corners. That's 4 up top and 4 below. So that's vertices equal 8. And if I know that F plus V equals E plus 2, then if this is 6 plus 8, which is 14, and that equals E plus 2, so 14 equals E plus 2 minus 2 from both sides, and I'm getting that 12 equals my edges. Okay, so let me change my color and say that edge equals 12. And I just did that by the math using my, let me see if I do that. Yep, using my Euler's formula. Okay, here's a little wedge of cheese. So you can think of that as a polyhedron. So what are the number of faces that this has? Well, it has top and bottom, and it has, so that's 2, 3, 4, 5 in the back. So the faces are 5. What about the vertices? Let's see, I have corners here, 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 and I have a corner here and a corner here. So I think I can see them all. So that is 1, 2, 3, 4, 5, 6. So I think I have 6 vertices. Okay, now we probably could count these edges. So let me make these edges purple. So here's an edge. This is 1, 2. This is 3. This is 4, 5, 6, 7, 8, and there's one more down below, and that is going to make 9. So my edges are 9. So in this situation, I counted everything. So let's just make sure that this statement is holding. So my faces, I have 5, plus my vertices makes that 11 on the left side, and 9 plus 2, that checks, it's 11 both sides. Okay, we have one more shape here. It says find the number of faces, vertices, and edges. So that's going to be our whole focus. So the faces, let's say I have here, here, and one in the back, and then one in the bottom. So that's going to be 4. My vertices, I'm going to color them in red. 1, 2, 3, 4. Okay, that's it for the vertices. That's 4. So if I want to figure out my edges, I could say F plus V equals E plus 2 if I didn't want to count them. So 4 plus 4 equals e plus 2, this is 8, equals e plus 2 minus 2 minus 2, 6 equals our e. Okay, e is going to be 6. Okay, let's move on to some more practice. And in this practice, we're not going to do all of it, just some of it. So, for our practice, we definitely need to know, and this is the homework, okay? So, we definitely need to know that f plus v equals e plus 2. Okay, so we have all the notes done. So let me give you some homework hints. You're going to do these, so you can do 1, 2, and 3, and you can do these as well, 4, 5, and 6. You can try these, okay? You can try these. So remember, the difference is prism and pyramid, okay? And a trapezoid looks like this. It'll give you an idea of how to start a trapezoidal pyramid. You can always look it up on Google as well. Okay, you can skip all of these. Okay, so we're going to skip, skip, and skip. You can do these, just kind of see what you figure out, and then you can skip these. Okay, so that's your homework assignment and your filled in notes. So please fill in your own notes and then go ahead and do the homework. And this completes the 11.5 video.